in your class, we left off getting ready to do average rate of change. We didn't actually get to start it, but we left off doing average rate of change.
It wasn't my phone, but I'm going to go ahead and turn on my page.
Okay. So, average rate of change. Okay, remember I was talking about average rate of change, and it's kind of like slope, except when we talk slope, we're talking about usually slope of a line, and so that slope is constant the whole line. When we talk about average rate of change, it's averaging slopes, because if we talk, like, for instance, about a parabola, that doesn't have the same slope all the way around. That slope is constantly changing. So average rate of change is looking at a certain interval, so like certain point to point, and finding the average slope there is kind of what average rate of change is. So now, definition, average rate of change of a function of y equals f of x between x equals a and x equals b. So from one point to another point, where a cannot equal b, that just means where there has to actually be a range. There can't be a and b being the same thing and there's no actual gap. There has to be distance between theirs. And you can see a and b written in interval notation like this such. So the formula we're using, f of b minus f of a over b minus a. When we talk f of b minus f of a, those are function values. So those are like y values. B minus a are your inputs. So those are like x's. So just like slope, and then it's y minus y over x minus x. Now, on example 3, let's look at example A. F of x equals x squared. And we're specifically being asked to find the average rate of change on the interval from x equals 2 to x equals 0. So, it is a negative 2. Did I not say that? Okay. So from x equals negative 2 to 0. Hopefully I would have used negative 2 at least. Now, so first of all, we need to identify our a's and b's. And our a and b value are the negative 2 and 0. I tend to go with a being the smaller of the two and b being the bigger of the two. Although, in my mind, unless I'm overlooking something, it shouldn't matter. If you switch your a and b and we do them opposite, we should in the end wind up the same. So if I'm using a is negative 2 and b is 0, then we also now need to find f of b and f of a, which means f of a means I'm going to be finding f of negative 2. If I'm trying to find f of b, that means in this particular problem, I'm finding f of 0. How do I find f of negative 2 and f of 0? Plug them in, right? If f of x equals x squared, then f of negative 2 means I'm going to be doing negative 2 squared, which is 4. If I do f of 0, that means I'm doing 0 squared, and 0 squared is 0. So what I just found is that f of negative 2 is equal to 4, and f of 0 is equal to 0. Can you set up your fraction for average rate of change then? F of b minus f of a is what goes on top. So what am I doing on top here? Okay, if we want to officially keep it in that order, 0 minus 4 over, so if we do f of b minus f of a, then b minus a is going to be 0 minus negative 2. So 0 minus 4 is negative 4. 0 minus negative 2 is plus 2. Negative 4 divided by 2 is negative 2. So average rate of change here is negative 2 on that interval.
You don't have to put that in anything else, it's just negative 2.
Mm-hmm. You can kind of tell that as 1 is 0 to begin.
Depends what your equation is that you're plugging it into, though. Because I wouldn't say that you could always tell that just because, I mean, in this case it was x squared. But like our next equation is different. Okay, let's try b then. This time it's f of x equals 3x squared minus 1, and it's from x equals negative 5 to 3. So what did I start off doing first last time? Yeah, find f of a and f of b. What are my a and b values? Negative 5 and 3. So we need to find f of negative 5 and f of 3. How do I find f of negative 5? Yeah. 3 times negative 5 squared minus 1. So negative 5 squared is 25 times 3, 75 minus 1, 74. Plug in 3. So now I'm doing 3 times 3 squared minus 1. 3 squared is 9 times 3, 27 minus 1, 26. So I just found f of negative 5 to equal 74. I found f of 3 to equal 26. Can you set up your fraction for average rate of change then? Okay, I can go with that. 26 minus 74 is f of b minus f of a, and then b minus a is 3 minus negative 5. 26 minus 74 is negative 48. 3 minus negative 5, 3 plus 5 is 8. Negative 48 divided by 8, negative 6.
You ever forget how to do this stuff?
What do you mean?
Like as you're going and teaching this stuff, you ever forget?
Oh, yeah.
Refresh yourself.
Oh, yeah. Oh, yeah. Depends on what the topic is. I mean, there's certain topics I don't, but there are definitely topics that I have to refresh myself at times. Okay, what about example C? It's f of x equals 16x cubed from A to C. What is that A to C? The A and B. So my A and B are now A and C in this example. Meaning, is my final answer going to be a number in this case? No, we're talking variables in this case. And so, if it helps you, by all means, I'm going to use A as A, but my B value is going to be C. Easiest thing, right? So if we start off finding f of A and f of B, what I'm really going to be finding in this case is f of A and f of C. What is f of A? (16a cubed). What is f of C? 16 times c cubed, or in other words, 16c cubed. Okay, there's not any cleanup you can do on that part. That's just every place we saw an x, we replace it with a and then c. Okay, so you ready? F of b minus f of a. What am I putting on top? Okay, 16c cubed minus 16a cubed. What goes on bottom then? C minus a. Now the trick on this one is simplifying. Is there simplifying that can be done, or how can I go about simplifying? Okay. I agree we can simplify.
Is it C minus A over
Okay, so, and what I was getting ready to say, and I wanted to hear what you guys had to say, there's right ways, there's a right way, and there's wrong ways to do this. Okay? Here's the deal, guys. This denominator is a C minus A. Because they are added and subtracted there, or in this case, subtracted. And the only thing we would be able to cancel or do with this is if there is another C minus A. Okay? Remember, we cannot, I know how tempting it is to just, C divided by C, A divided by A, or, A cubed divided by A, C cubed divided by C. But we can't do that because there's adding and subtracting. The way to cancel is to cancel in terms of factors, which means, let's do some factoring on top. Let's start with the obvious factoring on top. What do you see that's in common on top? 16. So let's start with the GCF. I expect you guys to be okay with that part. So if we factor out GCF on top, that means we're factoring out 16. What's left in my parentheses? C cubed minus A cubed. All over the denominator of C minus A. And again, I know we want to cancel here, like, I can just cancel a C, cancel an A. However, no, we have to think in terms of factoring. Morning class wrestled with this.
Can you take out the cubes?
You could just put in, make it C squared minus A squared.
Not exactly, no. Okay, so.
You can't take the cube root, can you?
No. And I know, that's what you guys want to do. You just want to take the cube root, or you just want to think, it's C minus A and C squared minus A squared. There's a factoring technique, and I swear we've done it at least once. Maybe only once. But about one person this morning remembered doing it once. Yeah, it breaks into, so this is the difference of